Hi, today we're going to do the lessons on graphing quadratic functions in standard form. Make sure you fill out the notes as we go along. If you have any questions at all, please write them off in the margins and be sure to ask me when you return to school. Okay, to start, we're going to start up with the warm-up. This is kind of a flashback to chapter 2 that we did. This is the transformations of a quadratic function. Now, if you'll remember, a quadratic function is raised to the second power, so the shape of this graph is a parabola. So what it's asking you, it's asking you to describe the translation of the parent function. Well, if you remember, in a parent function, so it's a parabola whose vertex is at 0, 0 and opens up. And then you're going to apply your transformations going from left to right. All right, this 2 right here is out in front. This would be considered our A. And if you remember back in chapter 2, this would be a stretch or a compression. Now, this is not a reflection because remember, a reflection is a negative out front. So this would be a stretch or a compression. So since it's 2, which has a value of greater than 1, that would be a stretch. And if you remember, a stretch is going to make it taller and skinnier. So this is a stretch of 2. Then the next move we have is plus 2 inside the parentheses prior to the squared, the little square there. So if you remember, again, this is the part that a lot of people forget, that inside the parentheses prior to the square, it's the opposite of the sign. So it's plus 2, but normally when you think plus 2, you think go right, but this one would actually be left 2. And then the one here at the end is minus 3, and that is down 3. Now these are going to come into play again today in this lesson, so hopefully some of that you remember will come back to you. All right, let's take a second and look at this key concept. This was taken out of the book. It says the parent function for the family of all quadratic functions is the f of x equals, that's where it always starts, again, a parabola whose vertex is at 0, 0. The graph of f of x equals x squared is a parabola shown below. So here's an example of what it looks like. And then it goes on to point out how this is the lowest point. In this case, it's the lowest point, but the highest or the lowest point in a parabola is its vertex, who at this case, the vertex is 0, 0. And then here, it's the axis of symmetry, divides the parabola into 2 mirror images and passes through the vertex. So one thing to always remember is that the axis of symmetry, okay, it's the x value of the vertex because it's going to be a vertical line that passes through the vertex. So the axis of symmetry, or the equation for the axis of symmetry, is always going to be x equals whatever the vertex, whatever the x value of the vertex is. All right, now let's move down here to example number 1. Graph a function of the form y equals ax squared. All right, graph y equals 2x squared. Then, it's supposed to be then, compare the graph with its parent function. Actually, let me put an n in there so I can fix it. All right, so let's think a second about what you know about this parabola. This parabola has a stretch of 2. It has no left or right moves. So hopefully at this point you know that because it's only the parent function, remember the parent function is x squared, the only change to the parent function is a stretch. So it hasn't moved left or right, so its vertex or of this graph is going to be 0, 0. So to make my life easier, I'm going to go ahead and I'm in the middle of my table of values. By doing that, it's going to give me I'm going to be able to choose vertex and points to the right of the vertex, and that's going to allow me to be able to graph this a lot easier. So to do your table of values, you're going to go ahead and pick numbers. If this is my vertex, remember, if this is my vertex, it's going to be if my vertex is going to go like this. So I need to the left of the vertex, and I need 2 points to the right of the vertex. So just to make our -1 and -2, that's the 2 points to the left of the vertex. Then you're going to do 1, 2 points to the right of the vertex. All right, guys, at any point, you can always pause this video too fast for you or talking too fast for you. That's kind of why this is going to work out, hopefully, for you. If you get ahead of you can always hit pause where you're not able to do that in the classroom. Okay, now how do we values? Now, in order to find our y values, you're going to plug this x value into the original equation. So what you're going to do is you're going to say y equals 2, and remember the original equation is x squared, but I chose to use -1. -1 squared. But keep in mind that this x is squared. So since it's 1 squared, that would be -1 times -1, which is +1. And then back over here times, and x is -1, y is 2. So you're going to go ahead and put your 2 in here. Then you're going to y equals 2 times -2. squared. Negative 2 times negative 2 is positive 4. 4 times 2 is 8. So when y is 2, x is 8. Now, because these are positive numbers, you don't have to think so hard, and I also know that these are symmetrical. I can also tell you that whenever x is positive 1, y is going to be 2, and when y is going to be 8. Okay, now what you want to do is you want to plot the points on the graph. Now, what I'm going to do is if you notice, I didn't draw the x and y axis, because this is start learning to gauge when you're given a blank graph. So because my high value is going to be 8, I'm going to go ahead and I'm going to put my axes down here, my x-axis real close to the bottom of my graph, and then I'm going to put my y-axis right in the middle. Go ahead and plot our points. I'm going to start with my vertex. My vertex is, then my first point I'm going to plot is going to be negative 1, 2, and then negative 2, so negative 2, 8. Now, it was positive 1, 2, and if you'll notice that right there, see how they're a mirror image? Here's my vertex. Here is 1 left, 2 up. This one is 1 right, 2 up. You can also compare it to the axis of symmetry. In this case is actually the y-axis. It would divide the parabola in half. So if I use that as my axis of symmetry, and I looked up here and I said, okay, this point is 2 to the left of the axis of symmetry. Point's going to be 2 to the right of the axis of symmetry. So there's the 5 points that I figured out on my table. And now I want to draw a smooth curve through the points. Remember, it's not a V. An absolute value is a V. So it's a little difficult sometimes to draw, so just do the best you can do. But basically, you're kind of like a U-shaped, and that's going to be your parabola. Now, it says compare this graph to that of the parent function. Well, if we had originally drawn the parent function, you would have known that the graph for the parent function would have been 0, 0, then it would have been 1, 1, then it would have been 2, 1, 2, 3, 4, and so on. So what's going to happen here is, normally, if this was the pencil drawing is the stretched parabola, this is actually going to be my parent function. So if you'll notice, the one that I drew in pencil is actually skinnier. So when it asks you to compare this graph to that of a parent function, make sure that you fill it out using a complete sentence and common sense and a little bit of an educated type of words. Don't just be quick at it. Because remember, when you take your EOC, this is going to be one of those situations to where there were differences. So how would you compare the two? You would say the graph of y equals 2x squared is due to the stretch of 2. All right, let's flip the page, go on to the next question. All right, we're going to try this again, but now we're actually having a full, longer equation. So in this one it says graph y equals negative 1/2 x squared plus 3, then compare the graph with its parent function. So again, about what you know. Pick your vertex. And that's what it says here. Make a table of values. Use what you know about the vertex to pick your x values. So what do we know? If we actually had to put this in the form of a parentheses x minus h all squared plus k, it would look like this. Negative 1/2 x minus 0 plus 3. And if you go back to lesson or chapter 2, I should say, this is your vertex here and here. So the vertex of this equation is 0, 3. So because it's symmetrical, I'm going to put 0, 3 right in the middle of my graph. Then pick 2 points to the left and 2 points to the right. Well, again, we can do negative 1 and negative 2. 1 and 2. You're going to take these values and you're going to plug them into where the x is in this equation. So y equals negative 1/2, and then it's x squared, so I'm going to say negative 1 squared plus 3. Negative 1 squared is 1, and half of 1 is 0.5, and it's times negative, so negative 0.5 plus 3. Negative 0.5 plus 3 is 2.5. So when x is negative 1, y is 2.5. Okay. Now, when y equals negative 1/2 negative 2 squared plus 3. So 2 squared is 4 times negative 1/2. So half of 4 is 2. So negative 2 plus 3 and 1. So when y is 1. Now again, I don't draw your graph, but if you remember, this is just use a little, you know your vertex is 0, 3. So if this is your vertex, and I'm just going to kind of show you how to figure this out. If that's your 0, 3, it opens down. How do I know? Because there's a reflection out front. So I know somehow my down. So if that's 0, 3, then you're going to figure out that that's up 3. So I'm going to go ahead and I am going to make my axis here. That's going to be my x-axis, and I'm going to make my y-axis here. So if 0, 3 is my vertex, then what I'm going to do is I'm going to plot the points. Now you might be asking, why am I only doing these points and not these 2 points? Because one thing you will find out about a parabola, or if you haven't figured it out already, is a parabola is symmetrical. So wherever you put a point on the left side of the vertex, the identical point is going to be on the right side. So then you don't have to worry about figuring these out. They'll figure themselves out. So my first coordinate is negative 1, 2.5. And then negative 2, 1. Okay? Well, now let's do the mirror image of it. It's negative 1. If it's left 1, remember this is your axis of symmetry, up 2.5, then the mirror image is going to be right 1 and 2.5, and then over here. So there are the points to this equation here. So I'm going to go ahead and it says plot the points in the table of your graph, draw a smooth curve. So actually, let me back up a second. We need to put these points up here. So it will actually again be 2.5 and 1. So you're going to draw your graph down, and you're going to draw your graph down. So that's the graph. But then it says compare this graph to that of the parent function. Well, remember, a parent function opens up. This one opens down. And then something else you'll notice is that this has a 1 less than 1, so that's a compression. So I'm actually going to take the graph and open it fatter. And a vertex is here. So when it compares to the parent function, you're going to say the graph of y equals negative half x squared plus 3 has a reflection. So it opens down, and a compression of 1/2. So it is, and we're going to use a really important math word here, fatter than the parent function. But don't forget that the vertex is also shifted. Okay, you can also say the graph is also shifted up 3 units. All right? Okay, so what you want to do, make your graph. You always want to make your table of values. You plot your points. You draw your graph. And then if it asks you to compare it, you go ahead and compare that. All right, the next section is your turn. You're going to do a couple problems on your own. So at this point, what I want you to do is I want you to pause the video. I want you to work out number 1, and then go ahead and start the video again and see what you come up with. I'll be waiting on you to come back, and we'll go through this together. Go ahead, pause the video. All right, welcome back. If you made a table of values, your table of values might differ from mine. It's quite all right, but one thing you will learn about me is I use 2 points to the right of the vertex and 2 points to the left. It's kind of like a standard form, because what happens with a parabola is if you end up getting 2 off the graph. All right, so this has a reflection and it has a stretch, so it's going to turn upside down, and it's also going to have a stretch, so it's skinny. But we didn't shift it left or right or up and down, so our vertex, and then as normal, I would pick -1, -2, and I would pick 1. After doing all the math, you'll figure out that when x is -1, y is -4. When x is -2, -8. And because it shifts down and I have a vertex of 0, 0, I'm going to go ahead and my graph up here right at the top. And again, your axes might be different than mine. So there's my axes. My vertex is 0, 0. And then we have -1, -4, do that mirror image, and then negative 8, and do that mirror image. So you might be tempted to make this one a V because it would be really easy. Just be careful. I'm not saying you can't. It would be, shame on you. But just keep in mind that with a parabola, mine isn't even that pretty. So when you do that, you just want to make sure you're careful and understand. The biggest concern is that you know that when you look at an equation that has an x squared term in it, that you know what the graph's going to look like. All right, now I didn't fill in these two because I told you it's going to be a mirror image. But when x is 1, y is -4, and when x is 2, y is -8. So here, there's your graph. So how does it compare to the parent function? Well, first off, graph of -4x squared down due to a reflection and is due to a of 4. Again, the biggest thing you have to understand here is looking at a quadratic equation, graph it, and understand what you're looking at. That's the biggest concern. Okay, next one, here's another example. Go ahead and pause these. My suggestion is if you think you're comfortable, you can go ahead and do both of them and come back to the video, whatever you want to do. But I'm going to go ahead and go, once you pause this video, when you come back to this one for you, and then we'll pause again and do number 3. All right, so go ahead and pause the video. All right. Now, again, table of values. You have an x value, and you have a y value. So let's think for a second where our vertex is going to be. We've talked about this hopefully enough that you're starting to figure it out. This is after the x squared, so that's your up or down move. So that means the vertex on this is 0, -5. So we're going to put that right in the middle. Okay? So again, and we also know that it opens down. So this is going to be a vertex that is really, I'm actually going to draw my graph real quick. Because it's already shifted down 5, I'm going to make it so that my axes, because we're probably not going to be able to get most of the graph on this, so I'm going to go ahead and do it like that. So we know that our vertex is 0, -5. 1, 2, 3, 4, 5. So there's my vertex. We also know that it's going to open down. So if we chose -1, now here's a trick. You need to be careful with this. This is definitely something that's going to get some of you. The equation is this: y equals the -x squared minus 5. Well, our x is -1. So when you actually plug that negative in 1 for x, that isn't the same as that. So it would actually look like this. So -1 squared. -1 times -1 is +1, but then it's the negative of that. So it's -1 minus 5, which is -6. So when x is -1, y is -6. Then if you're going to do a -2, it's the same situation. You can do these in your head too, or you can put them in your calculator, whatever works for you, but you're going to do -2 times -2, which is a +4, times the negative, which is -4. So -4 minus 5 is -9. Now, obviously, let's go back to our graph. Our graph is going to go off this, no way. If that's 5, we're going to have to make it all the way to 9. So 6, 7, 8, 9, we have enough room, so we're good there. But you might want to count by 2s if you don't think you have enough space. All right, so let's graph it. Here's 0, -5. Now let's try -1, -6. So here's -1, -6. Do the mirror image, which means when x is +1, y is going to be -6 also. And then you're going to go -2, 9. So if this is 6, 7, 8, 9, mirror image. So when x is +2, y is -9. Okay, again, shifts down. Okay, so then if back in the directions say compare it. So this one in this case is the graph of -x squared minus 5 is opening down, or opens down, whatever you want to write. And the vertex is shifted down 5 units. Okay? And again, there's no stretch or reflection, so we don't need to talk about it. All right, go ahead and pause the video again and do this one. Go ahead, pause it. All right, number 3, let's finish this one off before we move on. So again, you're going to make your table of values. Here's the funny part though. I'm going to tell you to make your table of values, but I'm going to do this one without a table of values because I'm going to show you that you don't necessarily need a table of values. I'm putting it there because some people like it, and that's fine, and I'm not telling you not to make one. This is where you have to decide if you understand what you're doing or not. Okay, I can look at this equation and I can see that the vertex is 0, 2. I also know that it's going to have a compression. So what do I know about this? I know that my graph is going to be shifted 2 units up. So because of that, I'm actually going to make my x-axis down here in the bottom, make my y-axis right here in the middle. We don't have any left or rights, but if we did, you might want to shift your y-axis a little bit. All right, so I know that my axis is 0, 2. 0, 2. All right, so same routine. You're going to put a -1 in here, so I'm going to fill this in as we go. So I'm going to put a -1 in. Now this might get a little bit difficult because if you're trying to do this in your head, but you can write it down. So -1 squared is 1. A quarter of 1 is 0.5. Okay, think about it. I have $1. What's a quarter of $1? A quarter. So times 1 times 1/4 is 0.25 plus 2. So when my value is -1, my y is going to be 2.2. Okay, and hopefully if you learned already that when it's -1, mirror image, this is also going to be 2.25. I'm going to put a -2 in there. So -2 times -2 is +4. 4 times 1/4 is 1. When my value is 2, it's going to be 1. So you're going to graph this. So you have -1 and then 2.25. Okay, it can't be perfect just because it's a little bit more difficult to do 2.25, but you get the idea. And -2, 1. Okay, -2, 1. Now, just out of curiosity, where would it be if, let's say, x was 5? See, if x is -5 or +5, how much would it open up our graph? Where would those points be? Because you see how close those are. So let's say for x. Actually, can we just do 4? Because I know 5 is hard to divide by 4. I'm doing it in my heads here. So if I put a 4 in, so let's go to 4. So if going on with our value, let's say if we put a 4 in, 4 squared is 16. Okay, and then 1/4 of 16 is 4 plus 2 is 6. So when x is 4, 1, 2, 3, 4, y is 6. 1, 2, 3, 4, 5, 6. Now what that does is it gives you a little bit of an idea of how to stretch out your parabola. All right. There you go. That would be what the parabola gives. Now, how are we going to describe this? We can do again, you always say the same kind of idea, or you can kind of describe it a little bit different. This one is, this has a compression of 1/4, so it is fatter, again, if you would, that math word, than its parent. I don't think that's apostrophe. Its vertex is shifted 2 units up. All right. Well, starting to understand this, you're already halfway there. Okay, now we're going to add a few things to it. This one's a little bit more work, but it's constantly repetitive, you know. All right, you have a couple different things here. It says, whenever a is greater than 0, the graph parabola is going to open here. When a is less than 0, the parabola opens down. Then, I don't know if you can see it right here, but there's a formula right there, and it says x equals -b minus over 2a. This is the formula for the x value of the vertex. You're going to use this formula every time in order to find the vertex, because what's going to happen is this is no longer in vertex form. The form that we talked about before gave you a vertex form. Now we're putting it into standard form, which makes it a little bit more work in order to graph the function. All right, let's take a look. Okay, example 3, graph the function in y plus bx plus c. This is actually standard form here. So standard form, if you're looking at it, the vertex isn't obvious. We can't go in there and go, oh, the number prior to the x is your left or right move, and the one at the end. It doesn't work that way anymore. So now this is standard form, and if you want to go ahead and circle this and write standard form, that would be a good idea. And what this does is it's still a quadratic function, and this is probably more of what you're used to seeing throughout Algebra 1 and geometry, but with this one you're going to have to do a little bit more to find everything. But don't worry, I walked you through the steps, and as long as you follow the steps, you should be okay. All right, first thing you're going to do is you're going to identify the coefficients of the function. Remember, a coefficient is the number in front of a variable. So compare standard form, ax squared plus bx plus c. So a is the coefficient of the x squared term, b is the coefficient of just the x, and c is the number that's all by itself. So the coefficients are a equals, well, in this case 2 is with the a, so you're going to put a 2 here. B is negative 8. You have to take a negative sign with it because the formula is plus plus. Now C is 6. And because A is greater than 0, the parabola opens up. Remember, if the negative out front is the reflection, which turns it upside down. So you should be able to look at a quadratic function right now and know that it's going to be a parabola that opens up or down. At least be able to do that. Okay, so in order to graph these, you need a couple things. You need the vertex. You need the axis of symmetry. You're going to need the y-intercept because these are going to be shifts left and right. And you're going to be able to find all of that very simply. Okay, so find the vertex using x equals negative b over 2a. And then I put, this is also the equation of the axis of symmetry. So to find the x coordinate of the vertex, you're going to do negative b over 2a. B and a that you see here comes from these coefficients. Go ahead and fill that in. So it's the negative of negative 8 all over 2 times 2. Okay, well the negative of negative 8 is 8 all over 2, 8 divided by 4 is 2. So we know two things right now, that the x coordinate of our vertex is 2. And we also know that this is the axis of symmetry. That line runs vertically through our graph in order to divide it in half. Okay, now we have x, x, y. You just take this value and you plug it back up into the original equation, which is what's right here. Then find the y coordinate of the vertex by substituting the x value you found into the original equation. So this x value is just going to replace the x throughout this equation. So you're going to put a 2 here and you're going to put a 2 here.